Hey, what's going on, guys? xiangqi here. In this video I'd like to demonstrate how the hexadecimal 88 board representation works in 6.502 assembly. So I've developed this Q1 emulator that has the built-in assembler, and we can do some hex dump here, even disassembling the code if needed. And I'm using this for testing, so we don't really have sort of a print board function here or something. So instead we're going to be looking, we're going to be inspecting the hex dump. And probably let's kickstart with this from 0 to 0x19, for instance, and I want to have the 16 columns. So here we'll have our chessboard being represented. I'll now upload the chessboard and then run the sample code to loop over all of the squares of the chessboard and to distinguish between those squares that are located on board and those that are off board. So something that we've been doing really, I don't know, countless number of times when we've been implementing this in C, in JavaScript, whatever. So yeah, let's have a look. Here I have two source files, and that's because we have the different origins for every of these source files. So here the variables are assumed to be loaded onto the so-called 0 page, because it's just faster for the 6.502 processor can access these variables faster, and also takes less code, less bytes to encode the instructions when we're dealing with a 0 page addressing mode. So it's pretty standard implementation. This is taken from my bare minimum chess program in C and JavaScript, but the pieces are represented not as decimals but as the hexadecimals, and I even have some I do even have some p-square table here being bundled into the board. So the idea that we have 128 long array of bytes. So the leftmost 64 bytes are the board, like 8 by 8 board, and the leftmost is the board, and the rightmost is the p-square table. So our goal is to distinguish this left part from this right part, and if we do manage to do so, that means that actually this hexadecimal 88 algorithm is actually working. And another important thing, and it's already dependent on the bit instruction for 6.502. So here I have the address, I call it, this is the label of board, and this is the address of hexadecimal 80. Here it's mentioned here, you'll now see why exactly. And here I have the constant of this hexadecimal 88. We're going to be bitwise ending the count, the square index. So this one, this one, this one, this one, this one, this, all this, and this would be treated as those squares on board, and as well as this and this, and everything goes to the left. And this would be treated as the off board. So let me just copy this and paste and assemble, and I want to set the origin to 0 and upload. And now if we have a look at the hex dump one more time, so from 0 to 0x19 and 116, and now this is important. So why do I want to display 16 columns? Just to make the layout of the board appropriate. So now we see here is our board, here is the board, and this is just the next line in the hex dump. And here we're only interested in this value 88, which we're going to be bitwise ending the index traversing through the board. And here is the address of hexadecimal 80, and this is the value, and this address just to reference, just in order to avoid referencing the address and instead referencing the actual sort of location. Here in the second file I have this definition for the so-called off board, and now here is the code. So yeah, let's probably start by running the code and seeing the output, and then quickly walk through the code to give an idea how it works. So I just paste this code in as well. I want to assemble, and this is going to be loaded at the 200 hexadecimal, which is quite standard location for Q1 at very least. So okay, and upload, and I'm going to 0 to 00. And here it is. And if I run the code, so Control G to run the code. So now the code has been run. And now all the squares that are supposed to be on board should be marked with the values FF. And that's just for debugging. It doesn't do much. So just to make sure that we do traverse the proper squares. So from 0 to 0x90 and 16, go in there, and here is the hex dump. So here we go, basically. So you see, like, the leftmost part where the actual chessboard is has been marked with FF, which means that we did implement our logic to traverse only onboard squares using this hexadecimal 88 sort of a principle being implemented properly. So we do have this, we do reference the onboard squares properly, and the rest, the offboard squares, which meanwhile serve the purpose of storing the p-square table values to give an engine an idea of where to develop its pieces, has been left untouched. So that's it, and this is the value that we have been doing this actual bitwise operation. So yeah, once the output is clear, now we can have a look at the source code, basically. So let's do it here. So I just started by clearing the decimal flag. So there's just standard initialization, reset in A and X register, and then so later on Y register would be reset to 0 as well. But for now, I'm using this just for this quick marking purposes. So it has the value of FF, and now here is how it is working. So at main, I just call this subroutine move generator and then break, and hence we just stop at this address, right? So calling the move gen function, move generator, here is the move generator, so it goes here, and here we have the loop over the board squares. I didn't yet provide the commentaries. We'll do this later on. So here is the loop over the board squares. So the first instruction, TXA, stands for transfer the content of the A register of the X register to A register, because if we have a look at this bit operation, what it does, bit sets the 0 flag as though the value in the address tested were ended with the accumulator. So accumulator in our case, A register, is holding the value of X register, which serves as a counter here, which gets clear later on. So we increment X every time in the loop, and then we just drop back here, right? So if we're done, then we just go in here and return from the subroutine, right? So but we can bitwise end the X register directly with a constant, for instance. So that's the limitation of the 6502 assembly and machine codes as well. So we first synchronize the values in the X and A register. So from after this instruction has been executed, we have the board index, the board square index being stored into the A register. Then whatever we have in the A register, we're bitwise ending with the value stored at offboard, and offboard is whatever content at the memory location of hexadecimal 80. And if we have a look again, if we have a look at the hex dump, what is there? We have the bind being defined there. So this concept of hexadecimal 88, that's the same what we've been doing in C and JavaScript. So it makes this it has bitwise ends the accumulator with this value, but it doesn't change the accumulator. So because bit operation doesn't change the value of the accumulator. If this was the end opcode, in that case it would be changing the accumulator. But since it's just a bit, it doesn't. And then branch equals means, so if the 0 flag has been set after this operation, in this case we know for sure that the square was actually on board, and here is the small routine to mark the squares with those FFs, right? So I'm just loading whatever value we have. Well, actually, yeah, this is not even needed for the examples. So here I'm going to be later on testing like whether the piece belongs to white or black, and depending on the time to move, picking up the appropriate pieces. So this line might be ignored for now. But in order to put those FFs into the hex dump, I'm using this STY. So the Y register, I already have this FF. So whatever index we have, so board, which is the address of 0, 0, so it starts from, this is the very first byte, so the board starts from the origin 0, 0. It's in the 0 page. So whatever the board plus the offset of x, which stands for square index, there we set the value that we currently have in the y register, which is ff, and that's just a handy way to distinguish between those squares being on board and those squares being off board. So those squares being on board are being marked with just being marked with those ffs. If we have a look at this again, and if we just limit ourselves to board only like this, for instance in 16, then here we go. Here is our board in the format of a hex dump, and the right part isn't touched, the left part being marked. So we make sure that we when we're looking for a source square for our piece to move, we're only going to be having a look at this kind of square. So that's pretty much all about the hexadecimal 88 system, how it works on lowest level. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.